In this lesson, we're going to do stretches and compressions. They change the slope of linear functions. So you could read that if a line becomes steeper, then the function has been stretched vertically or compressed horizontally. If the line becomes flatter, the function has been compressed vertically or stretched horizontally. I don't expect you to know that. What I do expect you to know is what you're going to do to the function. As you take notice in the first a horizontal stretch or compression, we're going to replace x by 1 over the factor times x. And a stretch or compression vertically, you're going to multiply the whole function by the factor. So let's look at the first example. First example says, let g of x be a horizontal compression of this function, f of x equals 2x minus 1, by a factor of 1/3. Write the rule for g of x and graph the function. Well, let's graph the original function first. The original function is 2x minus 1. What does that look like? It's in slope-intercept form. Intercept is 1, slope is 2 over 1, so up 1 over 2. I'm going to graph a few. Points. I'm going to draw it in blue. So there is our original function, f of x. We're going to write our g of x function. First off, it's a horizontal stretch or compression. So if you take notice, that means I have a factor. This factor is our b. What does it say to do? Replace our x with 1 over bx. Okay, so 1 over b, which is 1/3, actually equals 1 times 3 over 1, which is 3. So g of x, replace just the x, so the 2 has to come out, and I replace it with what? 1 over b, which is 3, x. And then I still write the minus 1. So that's 6x minus 1. So what's that look like graphed? Well, I graph -1, and I need to rise 6. 1, 2, 3, 4, 5, 6 over 1. Or down 6. 1, 2, 3, 4, 5, 6 over 1. And that's my new function. You have one to try. What's it saying to do? It's saying that I'm going to vertically compress by a factor of 1/4. So what does a vertical compression do? Vertical compression, if you look on the prior page, it says that you take the factor, which is now called a, times the whole function. So go ahead and write the rule. I would be okay with you leaving it in that form. However, I think the book might multiply it out so that it's in mx plus b form. 2/4, right, reduces, I'm just going to erase, to 1/2. Okay, so it's really a matter of comparing what it's asking for to your table, which again you're allowed to put on a note card, and deciding, is it a B factor or an A factor? A factors multiply the whole function. B factors are 1 over that B and replace the x. Sometimes we have a combination of transformations occurring. So I kind of wrote down the steps here for you for this example. We're saying let it be a vertical shift of this function f of x equals x down 2 units, and then do a vertical stretch by a factor of 5. We're going to write the rule. So the first thing you should do is perform the up, down, left, right, which is the translation. Okay? So, and it says down 2 units. Down 2 units, up and down, is outside the function. That means you don't put it inside the parentheses with the x, it's outside. So if I create a new function h of x, and I perform this 2 units down, down, up and down, up's going to be plus, down is going to be a minus. So it's just the function x minus 2. A stretch by the factor of 5. A stretch is, vertically, is a multiplier of the whole function outside the function. So my 5 is the a, and I'm multiplying the whole function by that. So my new function is going to be g of x 5 times my function. What is my function? X minus 2. So it's 5 times the whole function, which is 5x minus 10. You go ahead and try this one. So the first thing we do is a vertical compression. A vertical means I take the whole function, and I'm going to create a new function. I'm going to call it h of x. I take the whole thing times that factor. Okay, what is the whole thing? The whole thing, and if you need to, you put it in parentheses, is only x. So it's just 1/2 x. A horizontal shift, left or right, I should highlight that for you. Left or right goes inside the parentheses. This is going to be so what is my h of x? The 1/2 is going to stay out, and it goes just with the x. Oops. It's left, so it's plus, I'm sorry. And again, your book may multiply that out to keep everything in slope-intercept form. The last thing we're going to do is an application. So looking at this application, the function Rn equals 12.5n represents a club's revenue in dollars. where N is the number of purses sold. So a club paid $75 for the material needed to make the purses. Write a new number for the club's profit. Okay, so our new function is P of N for profit. Well, if profit is actually going to be revenue minus expenses, right? The amount of money you take in minus the amount that it costs you is how much you make in a profit. So this is going to be just 12.5 N minus the expenses. Graphing the two functions, I'm not going to worry so much about graphing these functions, but if you do it, the first function, you just plot some points. And if you plot them, the original function, 12.5 N, this first one's going to be at approximately 125. And 20 times 12.5 is 250. There's your original function. And then your new function minus expenses means you have to subtract out 75. So it's going to So again, plotting these points, I'm sorry, I just got an interruption of a why I'm missing school district phone call reminding you of your early dismissal on Wednesday. And there's what that would look like. And it makes sense. It's what it's doing. Transformation that has been applied is that it's been shifted. It's been moved downward, right? So it's moving down 75 units. So when it's moving up or down, that's called a vertical shift. And you could just call it vertical shift down. Okay, so let's do this, check it out. It says, what if the club members decide to double the price of each purse? Write a new profit, S of N, for the club. So doubling it, we're doubling the original, just the f of x part, we're just doubling this part, right? We're not doubling the whole thing. So we're only going to take 2 times that part. So S of N is going to be 2 times the 12.5 N. And the minus 75, there's still a set expenses. So when we multiply, there's our new function. They want you to graph on the next page. Okay, again, the graphing isn't so much a priority that we know how to do that. But the original function, do we remember what the original function looked like? It's counting by tens here, counting by hundreds over here. So we quickly just graph this. The original function is 10 at actually, I want you to plot P of n. I'm sorry. So P of n, P of n looked like this, approximately. And S of n, if you graph that, is doubling these numbers. And let's just answer this question real quick. What transformation has been applied? Because it's not the whole function, right? It's only the x that we changed. It's going to be this one, where it's inside the 1 over b. So how do we figure this out? Well, we say 1 over b equals 2, and we solve for b. Well, how do we solve for b? Well, I'm going to multiply both sides by b first, right? And then divide by 2. So b equals 1/2. And because it's a 1 over b type thing, if you look at your chart, that is a horizontal compression by a factor of 1/2.